Hello, my name is Aaron Celis, and my presentation today is on tidal current technologies. This presentation will show why tidal energy can hold immense potential as a renewable energy source due to a variety of factors. I will also go over this form of renewable energy's advantages, challenges, mechanisms, and current implementations. Why we need renewable energy sources. There are a variety of reasons as to why renewable energy sources are needed now, and even more so in the near future. For this slide, I chose to focus on two reasons specifically. The first reason is high energy demands. Liquid fossil fuels are currently the leading energy source around the world. They are widely used due to their conventionality and abundance. Abundance, however, does not equal infinite. A continuous reliance on fossil fuels will inevitably exhaust our reserves. To avoid this, it is essential to look for alternative energy sources, specifically those that are considered renewable. Another reason why renewable energy sources are needed is the cost of fossil fuels. As shown in the graph below, we can see not only a high consumption of liquid fossil fuels around the world, but also projected increases in oil barrel prices. This rise makes renewable energy a viable alternative as the source being used is of abundance and generally free to use. Ocean energy. Oceans make up about 70% of the Earth's surface and offer multiple renewable energy opportunities. Ocean energy can provide power in the form of tides, currents, waves, thermal gradients, and salinity. For the purposes of this presentation, however, we will be primarily focusing on tidal currents. These tidal currents provide many benefits in the increasing need for renewable energy sources. Tidal energy. Tidal energy has its advantages and disadvantages. Tidal energy is derived from the natural motion of tides caused by gravitational interactions found on Earth. Some advantages of tidal energy is that it is a predictable form of renewable energy. This is especially essential when pondering investing in such a source of energy. Tidal turbines that harnesses energy are very similar to wind turbines most people are familiar with. Main difference being that due to water being much more dense than air, tidal turbines are able to generate more power than wind turbines. Another notable advantage is that when implemented properly, tidal energy is much cleaner and more sustainable than fossil fuels. Moving over to the challenges of tidal energy. A very high investment is required for building tidal energy infrastructure. This is because of the complexity and tough conditions these harnessing devices must be in order to function underwater. As mentioned earlier, if not properly implemented, these systems can potentially impact marine wildlife. How tidal turbines work. Tidal turbines generally work very similar to wind turbines depending on the applications. These turbines are able to generate power by converting the kinetic energy in tidal currents into electricity. As previously mentioned, these devices functioning underwater make them able to generate more power than traditional wind turbines. Tidal turbines are generally made up of a rotor, blades, rotor shaft, gearbox, generator, and its structure, beginning with the rotor and blades. Large blades are configured on a hub creating a rotor. As the current passes through the blades, the rotor rotates. Next component is the rotor shaft. The rotor shaft is in between the rotor and generator, transmitting torque generated. The gearbox's role is to get the required RPM from the rotor shaft and transmit it to the generator. The generator then produces power with the received torque at the required RPM. A diagram of these components working together is shown below. These components, the structure, underwater cable transmit the generated power to land. The entire turbine is either set to the ground floor or floating, depending on its uses and some of its configurations can be seen in the figure below. Types of tidal turbines. Tidal turbines come in different shapes and sizes, but are generally seen in as three different types: axial flow turbines, cross-flow turbines, and oscillating hydrofoil systems. Axial flow turbines are most similar to wind turbines. Axial flow turbines are the most similar to wind turbines, having a horizontal axis parallel to the water flow. There are two types of axial flow turbines: open and shrouded turbines. Axial flow turbines are best suited for high flow tidal current. A diagram of this is shown below. Cross flow turbines are similar to axial flow turbines. However, they have a vertical axis perpendicular to the water flow. Similar to axial flow turbines, cross flow turbines can also be open and shrouded. These turbines are able to operate regardless of current direction. Oscillating hydrofoil systems. Instead of using rotating blades like axial flow or cross flow turbines, these systems use an up and down lever motion. This motion is ideal for shallow waters. Shrouded versus open turbines. Both axial flow and cross flow turbines, discussed before, can be configured as either shrouded or open turbines. Shrouded turbines are more efficient and can produce similar power to open turbines at a much smaller size. This is due to shrouded turbines being much more complex and intricate. These turbines also have more design flexibility. This flexibility, depending on the application, can often eliminate the need for a gearbox and can be made with inexpensive materials. As the name may suggest, the shrouds on the turbine make it so that it is resistant against weed growth and floating debris found underwater. Open turbines are much more simpler and require less maintenance. These turbines are less at risk of malfunction compared to the more complex shrouded turbines. Open turbines are also much more quieter and less disruptive to marine life. Choosing between these two designs heavily depends on the desired outcome and application of such turbines. Tidal current technologies. Below are several different applications of tidal energy harnessing devices. These devices are diverse, yet they share the same goal. The goal is to harness the power of tidal currents to generate power. Their diversity shows an increasing interest in developing new designs to be more efficient in their desired task or site. Tidal energy challenges. Briefly touched on in previous slides, tidal energy currently still faces many challenges. These challenges can be broken up into three major groups: technological, economic, and environmental. For technological challenges, these include the harsh underwater conditions the turbines must be built to withstand. The technological advancements in this field often find themselves in competition with more well-established renewable energy sources such as solar and wind. Economic challenges are a quite steep challenge to overcome. It's high upfront cost in building harnessing devices, and implementing them into the existing grid may be a deterrent to otherwise interested developers. Environmental challenges include the potential disruption of marine wildlife. Because this is a potential risk, strict regulatory standards put in place by world governments must be adhered to. Key contributors. Despite the challenges discussed in the previous slide, there is still a growing interest in maturing tidal current technologies. At the forefront of this interest is the UK. The UK leads the way in developing ocean energy systems according to the chart below. Other key contributors include the countries of Ireland, France, South Korea, and Australia. An important factor to consider in the development of these systems is governments and regulators. These two bodies play a big part in pushing developments forward through funding, friendly policies, and incentives for continuing research. In conclusion, Tidal energy is a promising renewable resource, offering predictable and abundant energy with minimal environmental impact when implemented responsibly and correctly. While there are challenges, such as high costs and environmental concerns, ongoing research, technological progress, and supportive policies are paving the way for tidal energy to become a mainstream energy solution. In this slide, I went ahead and listed a reference. This presentation was based on research from a paper by the name Harnessing Ocean Energy by Tidal Current Technologies by Mahmoud, Liang, and Khan. Thank you.